Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to work another example on hypothesis testing with the p-value approach. We're going to use the exercise that we used for the critical value approach just so that you can have a case that you can compare and see which of the two approaches you like best, or so that you feel comfortable with both of them no matter the exercise. So the data that we're using is, again, these are the notes that I used for solving the previous exercise. So we've got the beta hat 2.4, standard error being 1, and the sample size of 30. And we wanted to test whether the coefficient was statistically different from 0 at the 5%. So far the information is the same, which means that the first step where we define the two-tail test is going to be identical. Step 2, when we computed the t star, is also exactly the same, and so we're still 2.4 standard deviations away from the 0, and at this stage, again, we're still just looking at a distance. So the fourth step on the t-critical was that we had to find the critical value, which turned out to be the 2.5. So now for the p-value approach, instead, we have to define, so the alternative for that is we need to define the p-value, okay? And remember, the p-value is the probability of observing a statistic at least as extreme as 2.4. So if I am looking at the t-distribution table, I would want the legend to look like this, so that the numbers that are inside the table, they give me a probability that it's equivalent to anything beyond that number. And in this particular case, I know that my value is the computed 2.4. So I need a p-value, basically, that is associated with the 2.4. So the p-value associated to the t star, which was equal to 2.4. Keep in mind, the information is not changing. We still have a t distribution with 28 degrees of freedom, okay? We are still looking at the two-tailed test in here. So for the p-value, the thing is that the only 2 bits of information that we need are just whether we're doing a two-tailed test and the degrees of freedom, because two-tailed test is going to tell you the column, degrees of freedom is going to tell you the rows, okay? You can use a software or you can use the table, as I said, once again, but you will find that the p-value for this particular case is going to be actually, so p-value is going to be less than 0.05, okay? You can be as critical as you want. You can be like as precise as you want. This is very clearly like a case where we have something that is smaller than our p-critical of 5%, okay? In this particular case, you don't really need to draw the graph much because it's very clear that we will reject the null hypothesis, okay? This is also one of the reasons why most of the times whenever students see an exercise and they see a table where they have information on both the t and the p-value, they directly use the p-value to identify whether that coefficient is statistically significant or not. The p-value approach is just so much more direct, especially when this information is always given to you in the regression tables, okay? And keep in mind, because we are rejecting the null hypothesis in this case, this is exactly the same result we got with the t-value approach. But keep in mind that in the t-value approach, we asked that whether this 2.4 was beyond the cutoff. Now, in the p-value approach that we did in here was just to ask how rare this 2.4 would be under the null, okay? So same logic, same results. The p-value is usually considered to be more specific, like more exact, and a bit easier to get to the rejection or non-rejection decision. So feel free to experiment with both of them until you feel comfortable with both of them, and make sure you never confuse the two decision rules between one another. I hope this was helpful, and I'll see you in the next video.